Okay, so we got to solve this rational inequality. As soon as I see it's an inequality, I know it's going to be one of those problems with a number line, and we'll plot some points and we'll do some test values to see where the solutions are. So our first step is to figure out what are these points that we're going to plot. And the first thing we do to find those critical values, we solve the related equation 5 over x minus 6 equals 3 over x plus 2. All right, whatever solutions we get, that's going to go on the number line. So the way to solve this equation, well, one way to solve this equation is to make the denominators be the same. So I'm going to put x plus 2 over here, and I'm going to put x minus 6 over here in the numerator and the denominator. Now the denominators are the same. Are you with me so far? Yes. Okay. So now that the denominators are the same, I can cancel them out and make a new equation. So my new equation, distributive property, you know, is going to be 5x plus 10 is equal to 3x minus 18. And then I would subtract 3x from both sides, and that'll make 2x plus 10 is equal to negative 18. And then I'm going to subtract 10 from both sides, so that'll give me 2x is equal to negative 28. And then I would divide by 2. So that gives me x is equal to negative 14. Did that make sense? All right, so that gives me one of the values that will go on my number line. X equals negative 14. Luis, how do I get other values that go on the number line? You look at the excluded values. So from the x minus 6, I know that x cannot equal 6. From the x plus 2, I know that x cannot equal negative 2. So these three values are all going to go on my number line. So that's what we do. Okay, so here comes my number line. Okay, so I have negative 14. I have negative 2. And I have 6. Okay, remember that the excluded values are always open circles. So, because open circles mean excluded. So open circle on the 6, open circle on the negative 2. The negative 14 sometimes is open, sometimes is closed. What about this time, Luis? Open or closed? Closed. Anytime it's or equal to, it's going to be a closed circle to show that it's included in the solution. Okay, so now we're going to pick some test values. To the left of negative 14, I could pick, for example, negative 15. Between negative 2 and negative 14, I could pick, I'm going to just do negative 7. Between negative 2 and 6, I'm going to pick 0. To the right of 6, I'm going to pick 7. Okay, you don't have to use these exact same values. But that's what I'm going to do. Now in my calculator, anybody that was absent yesterday especially, this problem is slightly different, so please pay careful attention. And all the other problems, I could just put the left side of the equation in my calculator because I had a number over here. Usually 0, not always. But when I have a variable expression, I find it easier to rewrite this by taking this side and moving it over to the other side of the inequality by subtracting it from both sides. So basically, another way of writing this inequality would be like this. So I've got the 5 over x minus 6, just copying that down. But if I move the 3 over x plus 2 over to the left by subtracting it, I'm going to have minus 3 over x plus 2. And that's greater than or equal to 0 at this point because I've moved it, I've subtracted it. So this is what I recommend using this strategy whenever you have a variable on both sides. Okay? So now I'm going to put this in my calculator and I'm going to compare it to 0 again. So does that make sense, Luis? So in my calculator, table feature, okay, so it's 5 over x minus 6. And minus 3 over x plus 2. All right, and that's it. Make sure your calculator is in Ask X mode. Okay, so now I'm going to test out these 4 values, starting with negative 15 and negative 7. So I've got negative 15 and negative 7. Okay, so I've got negative 2 over 273. I've got 14 over 65. All right, and now I'm going to do a 0 and 7. So I've got 0 and 7. So that's negative 7 over 3 and 14 over 3. And we are comparing all of these. At this point, we're comparing to 0. Are they greater than 0? Okay, so comparing to 0 is easy because all we care about is positive, negative. So this is going to be no, yes, no, yes. Okay, and the yeses show us where the solutions are. So the solutions will be from here to here and from here on. So in interval notation, that's going to be bracket negative 14 to negative 2 parenthesis union parenthesis 6 to infinity. And that's it.